Okay, example 3, we're going to solve our quadratic equation using the square root method. And notice that we're missing one of our terms from standard form. Standard form is ax squared plus bx plus c equals 0. This little guy right here is missing. So if you're missing your x term, you can solve by the square root method. And when you solve by the square root method, you're going to get your x squared term alone. So I'm going to add 10 to both sides of my equation. I get 2x squared is equal to 10. Then I'm going to divide by 2 to get x squared by itself. And you get x squared is equal to 5. And then finally, to get rid of your exponent of 2, you're going to square root. And then what you do to one side, you're going to do to the other. Notice I left a little space here in front of my square root symbol because we need to make sure we write a plus or minus in front. And then finally, x is equal to plus or minus the square root of 5, and that is done. Now, in this section, it is possible to have some of your answers have a negative underneath the square root, and then you're going to have to take that negative out and turn it into an I. Up until this unit, we would write DNE does not exist whenever we got a negative under the root, but now in this section we are working with imaginary numbers. It's actually in section 3.1 before this section, and so now they're fair game. So if you have something like the square root of negative, 2, you're going to write that as a square root of 2i, or you can write it as I root 2, whatever you learned previously. Okay, let's go ahead and do example 4. Example 4 is going to be solved by factoring with the greatest common factor. Now this time you are missing something else. There's your standard form. This time you are missing the constant. So if you have a quadratic and you have both your x terms, your x squared and your x term, but you don't have that constant, then you can go ahead and try this and see how this goes. So I'm going to subtract the 14x from both sides. And then the 7 and the 14, those two terms aren't like terms, so I'm just going to scoot that 7x squared over and make room for the 14x. Set that equal to 0. And then we're going to go ahead and take out a greatest common factor. The greatest common factor between 7x squared and the 14x is going to be the 7x. And when you factor out a 7x, you are left with x minus 2. And then you can go ahead and quickly mental math distributing that through again and making sure you factored correctly. And then once you have it all factored up, you're going to take each factor and set your factor equal to 0. So each factor separately gets set equal to 0 in a mini equation. And when you solve the first equation, you just simply get x is equal to 0. And then this second equation, you're going to add 2, and you get x is equal to 2. Okay, so those are your solutions, 0 and 2. And then we're going to go ahead and do a little practice on the quadratic formula. The quadratic formula is nice when you have a trinomial that is not factorable, and this guy is not going to be factorable. So let's go ahead and go through our procedure. So what you need to do when you solve using the quadratic formula is you need to move everything to one side and set your equation equal to 0. All terms need to be to one side, setting your equation equal to 0. And then you're going to pull off your coefficients. A is coming off the x squared term. It's the coefficient of 3. B is coming off your x term. It's the coefficient of 2. And C is the constant, which is a negative 7. And then you can go ahead and plug into the quadratic formula and just clean it up. Okay, so we have x equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I'm going to go ahead and clean it up. I get plus or minus the square root of 4 plus all of these numbers multiplied together. Negative 4 times 3 times negative 7 is going to give you 84. And 2 times 3 is 6. And then you're going to get negative 2 plus or minus the square root of 88 over 6. And that's not done yet. This is where it gets a little bit tricky. Then we have negative 2 plus or minus the square root of 88 over 6. Okay, so that root 88 needs to be split up into two factors, where one factor is a perfect square. And the perfect square that divides into the 88 is 4. 4 times 22 gives you 88, and 4 is a perfect square. So once you split 80 up into those two factors, you can square root that 4, and the square root of 4 is 2. So you end up with root 88 turning into 2 root 22. And you can either split this up into two fractions and reduce, or you can factor out your numerator, which is what I'm going to do. I'm going to pull a 2 out of my numerator. And when you factor out a 2, you get negative 1 plus or minus the square root of 22. And then the 2 and the 6 can reduce to 1 over 3. And your final answer, all cleaned up, is negative 1 plus or minus root 22 over 3. And then you can split that up if you want to into two separate fractions, but that's, good for me. I'm going to leave my answer just like that. And then the last problem is going to be the method for completing the square. And completing the square is just like the quadratic formula. You can actually use it for trinomials that are non-factorable. However, it doesn't always work out that nice. It can get messy and it can get nasty. So I would only use it under certain conditions. The first thing that you need to do when you are completing the square is you need to isolate your terms with the variables, which means the 2x terms need to be alone on one side. Technically, my step 1 and my step 2 over here can be like interchanged, so I'm just going to go with the flow and complete the square in the order that I have here. So I'm going to isolate my x terms by adding 10 to both sides. And now my x terms with the variables are alone, and the 10's on the other side. The second thing that you need to do is you need to divide by a if your coefficient on your x squared term is not 1. And my a is not 1. My a is 2. So I'm going to divide everybody by 2. And this is kind of like the make or break moment, which is going to tell me whether or not my equation is kind of good for the method of completing the square. If this starts to become a nightmare from here, from this point on, I would just bail and do the quadratic formula. But I see when I divide my equation by 2, all my numbers are still whole numbers, and my b term in the middle here, that 4x, my b term is even. And that's what makes me say, hey, the completing the square is a good method. I have no fractions. My b term is nice and even there. I'm going to be able to split it in half when I need to, and my coefficient out front is 1. I'm good to go. Okay, so after you get those two steps done, which are actually interchangeable, technically it doesn't matter which one of these you do first, then I'm going to go ahead and add b over 2 squared to both sides. By adding b over 2 squared to both sides of the equation, I'm going to be able to factor the left side in a special way. So let's go ahead and look at b. b is equal to negative 4. It's the coefficient on the x term. And then I'm going to figure out what b over 2 squared is, and that is equal to negative 4 over 2 squared, which is negative 2 squared, which is 4. And then that's what I'm going to add to both sides. And I get x squared minus 4x. I'm adding b over 2 squared, and I'm going to add it to the other side as well. So this 4 just got added on both sides of my equation. And then that makes something special happen on the left side. You now can factor your left side. The right side I'm just going to combine to get 9. And not only am I going to be able to factor the left side, but it's going to factor into twins. This factors into x minus 2 times x minus 2. Factors of positive 4 that add to negative 4. There you have it. And because you always get twins when you complete the square, you are going to be able to write them condensed as that binomial squared. And now that I have it factored, I am on the last step. We are going to solve using the square root method. I'm going to clean off and remove that 2 by square rooting. And I have the quantity, the square root of the quantity x minus 2 squared. I'm going to also square root my right side. What you do to one side, you do to the other. Make sure you put a plus or minus in front of your root symbol. Now the x minus 2 drops out. On the right side, you get plus or minus 3. And then the semi-last step is to add 2 to both sides, and you get 2 plus or minus 3. Because you can take this a little bit further, and that 3 cleaned up to a nice whole number, then I'm going to go ahead and do that. X is equal to 2 plus 3, and then x is equal to 2 minus 3. And 2 plus 3 is 5, and 2 minus 3 is negative 1, and there's your answers.